Hi, welcome. So we've learned a lot of technical skills. We started with Excel, SQL, Power BI, and now Python. And we are also going to do now the project of Python and Express Data Analysis project, just like we've done for the others, Power BI, SQL, Excel. So here's time now for your Python project. After learning so much, you've learned a lot of things like basic data structures, functions, and also the packages like NumPy, Panda. So we are going to put that to use to be able to get some insight from a data set. And this data set is coming from Kaggle. So Kaggle is a data science competition website, but this data set is about using some income census data to be able to determine what are some of the features that are able to influence somebody to earn above 50,000 annual salary or less than 50,000. So I'm going to show you how you can go about getting your exploratory data analysis done. And this would be a framework for you to use. And then I'll leave you with some things that you need to do to complete so that you make this project your own and put it on your GitHub and share the links on your CV and to the rest of the world. So let's just go straight to the computer and see how to do some EDA with Python. So we have this folder, and in this folder, I have this income census file here. I'm going to show you. And also I have the Python EDA Jupyter Notebook here, which I'm going to open. So I'll just use the Anaconda prompt so that everything stays here, and I have these checkpoints here. So I'm just going to go here and go to Anaconda prompt, and then I'm going to do change directory, CD, Control V, then I do paste, then I do Jupyter notebook, and then now I'm going to launch now the Jupyter Notebook from within this folder so that everything is saved as you saw that checkpoint there. So if I click now here, I'm going to open that file, and from there now you can see we have our exploratory data analysis. So this one is twice here, so let me take this out. Now I press shift enter and we have our exploratory data analysis. So one of the things the Jupyter Notebooks is good is that you can be able to write like this with the markdown, even leave your comments in between your analysis, and it's good for data analysts when they use Jupyter Notebooks like this to communicate their findings at each point in time, as you would see here. So the data set here, if I click here, is coming from this Kaggle competition. So here are some of the fields. There's age, there's work class, self-employed, federal government, education, bachelor's. So all these occupation, crafts, repair, fishing, farming. So all these are to be used to be able to determine what are the probability of somebody earning above 50,000 annual yearly income or less than 50,000 yearly income. So we should be able to use these variables to be able to determine what are the probability of someone earning above 50K, for example. So if you are registered to Kaggle, you would have this data set on your own, but then I made it available for you here. I've just downloaded it and the file is here so that we can easily access it. So if we go here again, this is something that helps us to explain, and these are the steps. So generally you would import the necessary libraries like pandas, numpy, seaborn, which we have seen. You will try to get a big picture view of the data, like how many columns does it have, rows, so some general things about the data. Then you want to know if there are missing values. If there are so many missing values, then maybe the data is not good for the purpose, or you need to just check the missing values. And then you need to look at the dependent variable. So the dependent variable in this case, the income above 50K, less than 50K. So you want to see what's happening inside there. And then you also have now the independent variables, which are the age, as we saw, education, whatever. We need to see which of them influence this dependent variable. And then if necessary, you can also look at other relationships. And then you can even also have a conclusion. Why not? You can have a conclusion, and I'll leave that to you to be able to do some of these things like the conclusion. At the end of the day, what are the pertinent findings? What have you really found that is very pertinent and worth sharing? So you just remember you need to complete some of these things. So if we start now, we are going to create a markdown. Remember, you can either select from here or you press M. Then we would copy this first one. Now we are now on importing the necessary libraries. So I'm just going to do Control C, then make this a smaller header, maybe 2, then space, then I do one, maybe that's the first title, then Control V. So we want to import the necessary libraries, and you already know, as if you have been following the last few videos, we import NumPy as NP. I will not explain this again. That's how we have been doing. So you can always go back and look at the previous videos. And then we are going to import pandas as PD. Then we import matplotlib as well. Matplotlib dot pyplot as PLT. We import Cborn as SNS. So that's the general way we call this. Everybody's calling it that way, so you just maintain it. So matplotlib inline. So now we can just get this in, and we know that we've imported all the libraries that we need. And then we might want to also bring in the data to see. So we can say data set equal to PD. We have looked at things like this already. PD.read underscore, it's a CSV file, CSV. And we know that the name of this file is income underscore census.csv. So we are just going to type that in here. So we are going to say income underscore census.csv. So if we run that now, I'm going to call the data set so we can see it. So if we run that, we get this. And what we notice clearly is that already there are some question marks here, and this should be missing values. So we have an argument we can use here, which is saying that NA underscore values is equal to, now we precise that whenever you see this question mark, make them NA missing value. So if I run this now, and then let's see, we now have NaN here in place of the question mark. So we are able to eliminate those question marks and replace them by the formal missing values in Python. So now the next thing we wanted to look at now is the big picture. So we have this data in front of us. Now we need to quickly look at the big picture. I'm just going to press B for the next cells, and then here I'm going to press M for markdown. So the hash, then I'm going to say 2. This is the second section. So I'm just going to show you so that you have this framework, and it can be like a guide for you whenever you want to do your exploratory data analysis. So one of the things you might want to do with your data when you get it is to view the top data. So you can say .head. We've seen this before. So if it's a data set, that's the name of it, data set. So we see the first 5 elements, and then we can look at them. We see, okay, the less than 50K, less than 50K. We can also do a data set .tail. So if I paste here, data set .tail here, I see those below. And if I come here, I see, okay, there is a greater than 50K. So it looks okay. And the missing values that we saw here, so they are there. Everything looks okay. And we can decide to also look at what is the something like, we can say the shape of the data. So if I go and I want to be sure of the number of columns that I have and number of rows, so I can say data set dot shape. So remember, this one doesn't have it's just the attribute, so it's not a method. So when I run that now, I see that we have this number of rows and this number of columns. So I already know the size of my data. And then I can also do a dataset.describe, set.describe for the numerical values. So we looked at this earlier still. So just the age, education. So this one's like this education.num. This education didn't come through because it's not a numerical value. And then we have things like relationship that you wouldn't see here, race that you wouldn't see here, because the describe just takes the numerical values like these ones, not the categorical values. So you get your mean of age, the maximum age, the minimum age, 50 percentile. So all of this, you get that with the .describe. You could also use things like dataset.info. still you are trying to get the big picture, you're just looking. So you can see all your columns titles here easily, and then you can see that some of them are 32, some of them are 30. So this one to obviously have missing values, you already start getting. So it's also something that can help you to get missing values when we reach there too. So you're just getting an idea of your data. And then now you get the data set dot n unique. Now when you run that, you can see that you have your age has 73, so these are continuous variables. Sex has 2, male, female. Race, there are 5 races. Income, there's either greater than 50 or less than 50. So you can already start seeing if you have rare categories or so many categories. You can already start making you know if you have to regroup some categories together to be able to bin them or make them into bins so that it can be less, like 119 categories. You might need to bring it down if you need to. So it's still the big picture again. So you're just trying to see what is going on with my data. Now let's go on to the next one, which is the missing values. So we can now go to the missing values here, copy, Control C, go here, and I'm just going to press B for the new lines. Then I press M for the markdown, and then I'm going to go here and say 3 missing values. And then from missing values, now one of the things you can do easily is just to say data set dot is any, and then you can go to dot any. So when you run this now, it checks if there are any missing values, and you can already see, as we started seeing earlier, there's the true here, there's the true here, there's the true here. So we already know that those are the columns that have missing values. And again, you can just get a glimpse of that directly. So now let us move on then, and you can check on, because you could still use the describe, for example, the describe we used here, to see if the numerical values have missing values. You'll see them here. You'll see if they have less than what everybody else has. So if, for example, this one has 32.5, 32.5, 32.5, 32.5, 32.5. So we see that they don't have missing values, but you could still have numerical values. Maybe this could be 20,000, for example. This could be 10,000. So you know that you have lots of missing values here, for example. So with that, you can still spot missing values. Now let us go on now and look at the next one. So I hope you are getting the framework, the dependent variable, which is now what do we have, like what do we want to be able to predict somehow, even though it's not really predictive analysis here as such, but then just to be able to get something close to that. So this should be the foot. Yes, that's the foot. And then shift enter. Now we want to say, can we look at our income now? So let's go to data set, and then we can use our group by. Remember, we've looked at group by. So all these things, we are just bringing them together now to solve the problem, which is exploratory data analysis. But we have looked at these bits and pieces of these things already. So our group by, you have income, and then you have to close that first, so that now you have your dot size there. So you can already see there are 24,000 less than 50K, and there are just 7,000 above 50K. So that is one information that you get instantly. And then I could get now them like, I could get them like a proportion. So if I want to get like a proportion, I might just add a count and then divided by the length. So for example, if I get this, I might just bring in age, just to be able to, let me just type it, and then you'd see. So I can say age.count now instead. So I can say age.count. So count that, and then now broken down in terms of income, and then now divide by the total length of the data set, so that we can get it like a proportion. So it's just a simple mathematic and playing with your formula. So now I know that this is like 75% or 76%, and then this is like 24% here. So I already have an idea, and I could decide to use now Seaborn. So remember SNS, with the single line, you're able to plot lots of things. So you would be using SNS a lot because it's easy to use and it assumes lots of things for you. but at the same time, what it assumes is exactly what you've been looking for most of the time. So you have your data set here, and then now if you run this, you have your your chart. So you can already see here, column chart here, less than 50k. So you can, as you saw here, this one is about 24%, this one is about 75%. So this one is like maybe 3 times this one. So you'll be using it to know that this is how I'll judge if some distribution is out of this normal. So if I press B and I press M here, so I could leave a comment, for example, which is the beauty again of Jupyter Notebook. So we notice that earning above 50k, for example, constitutes only 24%. So 25% of the data set, for example. So this is a comment that you're leaving, and this is one of the beauty of the Jupyter Notebooks. You can leave comments along the line as you go, so that even you or somebody looking at it later will be able to relate or be able to know what you were doing or how you came up with your conclusion. So now these are the independent variables. So I'll just show you a couple, but you can take your time now and look at each of the independent variables and see how they correlate to the dependent variable. So hash, shift enter, and then we can now start with H. So I can just get another B here, space, and press another M for markdown, and then I can just say, for example, a smaller title 3 times 5.1, for example. It can be any labeling, but the idea is just that you want to treat them, these variables that you've seen here, you want to try to treat them and see how each of them affects the income here. So we're starting with age, I'll show you, and then you can also do the same for the other variables. So data set dot age dot describe. So you might want to see what age looks like. Then it gives you the minimum, mean, maximum. You can already see what is there. And then now you might want to do a plot. You can use a group by to do it very easily. So data set dot group by, then you get age, and then you do a dot size, which we have seen in previous videos already. So we group by age, we close this, then we get a dot size and dot plot here. So if you run it, see we have this plot of age, and then we see already the distribution. So there are many this way, and then we could decide now to use SNS to get a better plot. So if I say, for example, sns.count plot, so you use a lot of count plot, equals to, now my x is age, so, and then the hue is just the color. So hue would be income, should determine the color, the income, different income categories, the two, and then we have the data. We need to tell it the data set. So if you run this, we see that we have something like this. But then what we could do now is bring now matplotlib to come and support Seaborn and increase the size of that chart. So I'm going to do a plt.figure and say fixed size equal to, maybe just guess, maybe let me just try 15 by 10. So you're going to see, then when I run this again, you see the chart has been extended, so I can be able to see the edges now better. I could still add this, but then you see already that this is the blue is the less than 50k, and the orange is the greater than 50k. So from here, for example, when you see this proportion like this, you see that you expect something like this height. Maybe this one should be like 3 times the other one. So this one should be stacked up like 3 times if you think of it visually. So if I come here, I see that maybe this one here, I can stack it up a second time and a third time. This one looks okay. But when I start getting to these ages like 36, if I stack this one here, it's already almost here. The third one will be above. So we start seeing that the age might really be a huge influence on this distribution that we expect to see here, the average distribution here. So that's how you use your statistics skills to be able to conclude that you think that people maybe above 36, there's a higher chance of getting close to this one, the greater than 50k. So you have higher chance. So you need to look at when this one is almost close to this one, and then you can be able to get detail on that one here. So you might now be able to say here, for example, let me put B and put spaces here, put M there. You might be able to say again your comments that we notice. For example, we notice. So these are some of the things that you'll be doing with each of these variables. So I'm just showing you an example with this one so that you see how you'll be doing it with the other ones and based on the skills you've learned. So we notice that maybe from age 33, for example, 33 to 59, there is at least, for example, there is at least a 50% chance of earning above 50k, for example. So this is just using your statistics, using your technical skills, using your visualization to be able to clearly tell here that this is what we expect to see from this data set. So there are lots of interesting things you can do with this data. So you might just need to pick up each of those variables and use your skills to be able to build visualizations behind them so that we can be able to see clearly that, okay, this is the relationship that this one has with the other, this is that. So things like that. So if, for example, you look at things like your hours per week. So let's look at hours per week, for example. So we did age. Let's look at hours per week. And then I'll show you some of the things you can do with your EDA. So here, I'm just going to get Markdown. And then I'm going to get here is 3. So this should be the third. So we can say 5 point. Okay, the second 5.2. 5, maybe 0.2. Was it point or comma? Let me see. 5 point, yes, 5.2. So you're going to look at these variables like each of them. So we can say here hours per week. Hours per week. So I'm really looking at how you guys are going to complete this with the other variables. So for example, we could say we want to look at the hours per week. So I'm still going to use a group by. Remember, the group by is very interesting. Dataset.group by. So you can always go back and check the video when I mentioned that the group by is something that you need to really take a look at. So if I put now my hours dot per week, because that's how it's spelled. So if I put my hours dot per week, and then I could decide to do my hours per week and income, for example. So if I get income here, income, and then I do a dot size, for example. So when you run that, you get something like this, and then you can do a dot plot, for example. And then you can say maybe your kind. So let me first do a dot plot. So this is your plot, but then you can convert this to a bar plot first by doing some binning here. So we did floor division, and if you remember, if we take something like 23 divided by maybe 2 or so, we get this point. But if we do floor division like this, we get just 11. So anything between 23 and 29. So if you see, let me just say, for example, divided by 20, we get that 1. So if I get divided by 21, we get that. Divided by 29, divided by 29, we get the 1. But if I move on to 30 or so, I get 1. If I move on to, so if you do this, for example, with 10, So if, for example, I have any number like 9 is 0, if I have something like 11 is 1, if I have something like 19 is still 1, but if I have something like 21 is 2, something like 29 is still 2. So we could use our knowledge of floor division here to play with this hours per week and come up with a bar plot here where we can easily see what is happening there. So if I do the double division, I multiply by 10, then I do a multiplication by 10, divide by 10, then I multiply by 10. So it's like doing this 29 by 10. For example, let me go to times 10. Then you divide again by 10, or you divide by 10, for example, then you multiply by 10. So if I run this, I get 20. So if you see here, if I get 21, so it's 20. So it's like binning. So if you understand your statistics, you'll see that I'm trying to create a bin here. So anything from 21, so if I get 29, anything from 21 to 29 will be in the 20 bin. So let me run this here. So we have this like this, and then I could decide to put a bar plot here. Kind equals to a bar, for example. So if you run this, you see we have an interesting bar plot, so we can easily see that in the 20, 21 to 29, in this range, this is what we have. This is what we have in the 30s, this is what we have in the 40s. So we see many people did 40 hours per week, and then we have some people 50 hours per week. So we could decide to say we want to see if we group this maybe by less than 40 hours per week or greater than 40 hours per week. So we are trying to create now new feature. So we could say, for example, data set. So let me copy this. Let me copy this just to save time so that I'll not be typing again. So data set, for example, we can create now a data set week 2, for example, equals to, we will now use an np.where data set. So this like an if condition. So where, let me paste that data set here, where if data set this is less than 40, for example, less than 40, then we put below 40, for example, below 40, and then we can also get an above 40 as the else statement. So if you've been doing your if with Excel, you should understand this very easily, or Power BI. So we are just saying np.where, just think of it like if data set hours per week is less than 40, make data set hours per week 2. So this will be a new column. Create a new column where it is based on this first column, hours per week 1 or so. So if this hours per week, anytime that it is less than 40 from here downwards, just create one category and call them below 40. And anytime that is above 40, just create another category and call them above 40. So it's just an if statement like that. And then if you now even run your data set, you'll see that it has a new column, for example. So I could just run the data set even here, data set. So we could see that we have a new column, hours per week. So this one is above 40, this one is below 40, or we could say 40 and above, for example. So we could say 40, better wording, 40 and above, it's better. So if you run it, we see that here we get 40 and above, 40 and above, anything 40, 40 and above, anything below 40, below 40. So you can now even use that now to plot your new graph or your new chart and be able to come up with some interesting insight. So if, for example, we decide to plot or we want to see, so we can say, for example, dataset.group, dataset.group by. So, or we can even use a count plot. Let's just use a count plot so you can see it clearly. So I'll just say sns.count plot x equals to now hours dot per dot week 2, now week 2, and then we say our our hue is income. Our hue is income. And then our data is data set. So when you run this, you see you get this now. So you see already that the 40 and above, we have maybe almost the double 2.5. So this you work 40 and above, you have a higher chance of earning the greater than 50K. And this one now, you see it's really way below this distribution. Still again, I'll go back here we are referring to this again. So it's just some mixture of your statistics and then your technical skills and then your communication skills to be able to come up with very interesting insight for the data. So you can continue along the same line with maybe sex, for example. So if, for example, you take sex, so this was 5 point, this was okay, so here we had 5.1. So normally this is 5.2, 5.2 here, enter, and then we could just double click here, copy this one, take it down here, and then we paste, press M here, and then we call it maybe 5.3, and then we say this is sex, for example. So I'm going to do sex, and I hope you continue to do same for the others using all the tools and skills that we've learned before up to this date. So group by, and then you get sex. So because I don't want the video to be too long, but then the concepts are already there and you'll be doing basically the same thing. And with your count plot, you do lots of things like your SNS count plot and also your group by. So I can call this kind equals to bar. Remember the same thing you can plot with your SNS, but then you want to use so you can see the male, the female, you can get the proportion of how they are there. And then you can even decide to use a count plot to get a hue and see. So if I do an sns.count plot, and then I say, for example, x equals to sex, and then I get a hue, x equals to sex, and I get a hue equals to income, and then also I decide to get data equals to data set, for example. So when I run this now, you can see that I can also see the proportion. I see that more male can earn greater than 50K because this is like 2.2 or so, but this is like so many times, maybe 5 times for this to get here. So again, referring, still again, using some statistics and referring to this. So you see that you can leave your comments here after each of these findings, and then you can continue to explore the other data sets here that you saw. Like you looked at age, you can look at work class, education, race, sex, native country. So you can look at that, each of the variables, and then even try to find other relationships between the variables, like you've seen here, number 5 here. Try to find relationships between variables, and also at the same time get your conclusion so that you can be able to conclude, okay, do I see that what is finally maybe a good thing to conclude here. So for example, I'll just show you one example here. So if, for example, I want to get other relationships, I could go here and then I just go down here, and this would be 6 now. So I can press B, and then I say this will be 6. And then this is also a markdown. And then I'm going to press other relationships, for example. So we could decide to get a relationship like SNS, for example, count plot. So this should really be an interesting exercise for you to put down your Python knowledge, so that marital.status is the first one. Then I'm instead going to get the hue as occupation, not income, occupation. And I want to see how occupation plays. So later on, I'll see how income can be decided by these two variables, for example. So if you run that, let me see. Okay, so marital status, hue is occupation. Let me get that sns.count plot, x equals to marital.status, hue is equals to occupation, and then data equals to data set. So it's telling me that I have a positional argument follows the keyword. So data equals to data set. So let me see what is wrong here. Normally I should have, okay, here, yes. So here is the issue, the hue. So if you run it, you see that you have something like this. And of course, you can use again your matplotlib to extend this. So if you remember what we did here, so just get the pattern. Let me show you. So you see you have it already. Maybe something like this. We could decide that, okay, why don't we try a size like that here and then adjust the length and the width based on what we have. So we use matplotlib and then we run it to see the difference. So we see here how the distribution of the different occupation based on this widow. So you can try things like that: marital status and occupation, maybe sex and education. You can try things like that for the different combinations. To when you finish doing your independence, this one here, you get some insight from this one, and then you start trying other combinations. Like from these independent variables, you start seeing, but does age have anything again to do with maybe education? How can we get a correlation? So I hope to really see you take these other relationships and of course at the end come up with very powerful conclusion, which I'll just copy this one and paste here. Conclusion here, press M, and then you can now say this is conclusion, because this, where is it coming from? This is coming from here, from here. So we are just going to come down now and say, after you do all those things, we want you to be able to come up with a very good conclusion overall. I've seen that age and education or sex really have a huge influence. So you're going to do your mark down here, and then you say maybe overall. That's what you're going to type lots of things here, so that at the end of the day, somebody looking at your notebook would see the introduction, see the things you cover, and you're importing, you're having the big picture, you're looking at missing values. You see that I have dependent variable, this is how they behave, this is what I expect to see. And then each of the independent variables, do they behave like what I expect to see here, like the distribution, like we saw here. Each of the independent variables, you're going to go through them, sex, all of them. And then at the end, also try to see if there are any correlations between two variables and how you can mix two things to come up with some other insight. And at the end, you come up with some very interesting conclusion. So I'm really hoping to see what you guys would do. So I hope I've been able to give you a framework that you can use for your exploratory data analysis projects, thinking through importing the libraries and all that, going through these steps towards concluding and being able to come up with very interesting insight and disruptive ideas that nobody has seen before in the data set until you did this very, very deep exploratory data analysis. I hope you enjoyed the video, and you're also going to return with your findings and your projects and share the link so that we all can see what you've taken this and turned it to your own and you're able to do. So see you next video. Wish you good data luck.